this question, we will solve a trig equation that's in a quadratic form. So we can think about sine squared theta as sine theta times sine theta, which is actually sine theta squared. First thing we have to do is square root both sides. Remember the plus or minus, because 3 times 3 equals 9, but negative 3 times negative 3 also equals 9, so the plus or minus is very important. We need to simplify, and we can split this apart into the two factors. It'll make it easier to move forward by having two separate equations. We can use the cast rule. Sine theta equals root 3 over 2. This is positive. Where is sine positive? At the A and the S, the first quadrant and the second quadrant. We draw our special triangle. The opposite is root 3. The hypotenuse is 2. What is theta? Which special triangle is this? Theta is equal to pi over 3. A trick to remember this is there's a relationship between the angle and the opposite side. The longer side has the bigger angle. The smaller side has the smaller angle. Is this the only solution? No, there is one other solution in the second quadrant, and it will also give sine theta is equal to root 3 over 2. The angle here is theta, the angle here is theta equals pi minus pi over 3. It's a good idea to write out your steps so you don't make any slip-ups. With fractions, it's easy to make a little mistake. So pi equals 3 pi over 3, and now we can subtract to get a common denominator. Now we have two solutions. Remember that the sine function is periodic, and it goes up and down, and there's multiple solutions. Here we're working from 0 to 2 pi. So we still have a couple more solutions that we can use. Sine theta also equals negative root 3 over 2. Where is sine negative? We need the cast rule. Sine is negative in the third and fourth quadrants. We draw a special triangle. We're missing something here. One of these values are not quite perfect. What's missing? So for these two angles, we have pi plus pi over 3. Oh, that's what we're missing, the negative. Because they're negative y values. And 2 pi minus pi over 3 is the value in the fourth quadrant. Again, try to write out your steps so you don't make any mistakes working with the fractions. You can also look up the question logically to make sure that it's a sensible answer. So the first one's 4 pi over 3. That's just a little bit more than pi, because we have 4 over 3, which is a little bit more than 1. So that makes sense that it's in the third quadrant. We want to write out all of our solutions. It's helpful for the person reading your work with your final solution if you do something to draw attention to it. Circle it, box it, highlight it, something like that, so people know it's your final solution. I like to put a box around it. How do we know that this is correct? We have answers between 0 and 2 pi. How do we know we didn't make a mistake? We used pi over 3. What if we accidentally picked the wrong angle? What if it was pi over 6? And we did all of this work and got all these questions based on the wrong angle written in special triangle? Well, of course we do a check. How good your check is might depend on how much time you have, but it's a good idea at the very least to plug it quickly into your calculator and make sure that it works. For this check, I used the special triangle to get the value for sine theta. The special triangle told me root 3 over 2, and I get the solution. What if my mistake was the special triangle? Then this may not be the best check, because I'm not checking if I picked the right special triangle. A different way, and probably better way to check your work, is to use a different form. Maybe use the graph, or use your calculator. Up to this point you haven't used the calculator, so it might be useful. If you put sine theta into your calculator here, you're going to get a really, really ugly fraction. Sorry, not a fraction, a decimal. And it looks like it doesn't make sense, but if you take that value and then press squared, then you will get 3 over 4. So that means your answer is the square root of 3 over 4. That's a little hint in this section for trigonometry. There's a lot of square roots. If you square it in your calculator, the ugly number that comes up, you should get a nice whole number, and then you know your solution is the square root of that number. So you can continue to do checks for all of your values. Maybe write it out one time, and then all the other times just plug it quickly into your calculator. You don't need to write quite as much as I did here. I just wrote it all out, so it would be a good example. I like to give myself check marks. One thing that these checks wouldn't check for is if you went outside of the 0 to 2 pi interval that we had, when you plug the value in, it would still work in your calculator, so that it wouldn't check the interval